हेलो स्टूडेंट्स, कैसे हो आप लोग? ओके, आज हम लोग फिर मोशन इन प्लेन का अगला टॉपिक करने वाले हैं। हम लोग वेक्टर्स के टाइप कर रहे थे, राइट? वी वर डूइंग टाइप ऑफ वेक्टर्स. सो टिल नाउ वी हैड डन इक्वल वेक्टर्स. सो इक्वल वेक्टर्स, व्हाट आर इक्वल वेक्टर्स? एक बार फिर से रिव्यू कर लेते हैं. इक्वल वेक्टर का मतलब मैग्नीट्यूड एंड डायरेक्शन दोनों ही इक्वल होने चाहिए, राइट? A and B are equal. A and B are equal when both have got equal magnitude and equal direction. Same magnitude and same direction. Same magnitude and same direction. Then only the two vectors can be equal. Okay? One thing. Second thing, let us do one more. How parallel vectors and equal vectors are different. Suppose we have two vectors of unequal magnitude. Suppose this is A and this is C, right? A and C, and again this is A and this is B. Here A is not in equal magnitude. When we say magnitude, we say modulus of vector, right? We only find out the length of the vector. Okay? Only find the length of the vector, that is magnitude only, right? So if we say that they have unequal magnitude but same direction, unequal magnitude and same direction. Here A and B are equal in magnitude and equal, and they've got same direction. So do you think that these two are parallel? Can we say that both the set of vectors are parallel vectors? Can we say that? Yes, these two are parallel vectors. Also these two are parallel vectors. So what we need to do is, we need to understand that equal vectors have same direction, that is they are parallel, but they have one condition, that they have equal magnitude also. Whereas parallel vectors, two vectors with unequal magnitude can also be parallel. Can we say that? Two vectors with unequal magnitude can be parallel when they have same directions, right? When we say same direction, what do you mean by that? If it is inclined, suppose vector A is inclined along x-axis, B should also inclined, or the C should also incline in the same x-axis. Understood? So unequal vectors, when you are saying unequal vectors, there can be change in magnitude, right? They might not be equal in magnitude. Unequal vectors might have same direction but may not have same magnitude. That can also be termed as unequal vectors. So equal vectors, okay. Unequal vectors, fine. That also we have understood. Parallel vectors, that also we have understood. So these things are very simple, basic terminology that we need to keep in mind, okay? All right, let us move further. Coplanar vectors. Now I would like you to visualize properly. 3D visualization should be there. 3D. Suppose you are inside a room, mark one of the corner to be the origin, and like this you can do. This is the origin, this is x-axis, positive x-axis, from left to right, okay, from this to, if you go further in this direction, this is xy plane, this is x, this is y, this is z. right? I want you to understand this very simple thing. We have marked this. What we have marked? 3D diagram, right? Just take a look. This is x-axis, this is y-axis, this is z-axis. So can we say that this one is YZ plane, this one is YZ plane, this one is also YZ plane? So we need to have this clear vision. I would tell you this is all the pair of this YZ plane. This is YZ plane. Then we have XZ plane. I'll mark it. I'll draw properly. Okay. This is YZ plane. YZ plane. Right? Now, let us draw another. Now, we have got the idea behind XY plane, YZ plane, and XZ plane is also there. What would be XZ plane? See, X, Y, Z. When you say XZ plane, that means it should be like this and this. So, third plane would be this. YZ plane, XZ plane would be this one, and you have this one behind this. You can see this, right? X and Z. This is XZ plane. XY plane is this. YZ planes are this. Just have a look. XY plane. These two are XY plane. These two are YZ plane. These two are XZ plane. So that, if you keep in mind, would be always good. You can visualize things properly. Now, as per our definition, we were like to do coplanar vectors. The two vectors which are on the same plane. Suppose you are saying one of the vectors is along XY plane. Okay. Another vector also along one XY plane. So these two are coplanar vectors. Okay. This A and B. This A and say D. A and D. So these two are coplanar. These two are coplanar. We mark this one differently. Okay. This is C and this is D. So what did we observe? We have observed that C and D are coplanar, whereas A and B are coplanar, right? And C and A are not coplanar. They are non-coplanar. So when you are saying non-coplanar, that means the two vectors are not placed on the same plane. They have got different planes. Okay, so non-coplanar. So this we understood. Now, planar, coplanar means vectors which act in the same plane. That we understood. Non-coplanar is what? Non-coplanar. They do not act along same plane. Act along same plane. Okay. They have got different plane. Right? Now, next type of vector, co-initial vector. When you say that the two vectors have same starting point, they start from the same point, are called co-initial vectors. Okay? Like suppose I have vector A and I have vector B. Suppose this is vector A and this is vector B. They all start, both of them start from A. We may have another vector C. So all the three vectors are co-initial vectors because they all start from this point O, right? Okay, move further. Collinear vectors. Vectors which either act along the same line or along parallel lines. Collinear vectors. Okay, that we understood. Coterminous vectors. Vectors which have common terminal point. When you say common terminal point, suppose they start from somewhere. Vector A started from somewhere and vector B also started from somewhere, and both of them terminate here. Both of them terminate here. So we would say that the A vector and B vector are coterminous vectors. Right? Okay, move ahead. Negative of a vector. This is very important. When you have to do relative velocity, we have to understand this negative of a vector. And for vector subtraction also, we have to understand what is negative of a vector. Okay, just have a look. When you say negative of a vector, what actually you are trying to say is that the direction of the vector is opposite to the vector, right? The negative of a vector, suppose this is vector A. Vector A is acting along positive x-axis. When you are saying negative of a vector, that means it is acting, the same vector is acting along negative x-axis. So that we may consider, acting along, this is positive x-axis and this is negative x-axis. If the same vector is acting along the opposite direction, this is negative of vector A because this is acting along this direction, negative of x-axis. Negative x-axis. If this vector is acting along negative x-axis, earlier we had this A acting along positive x-axis. We have taken this to be acting along negative x-axis, opposite direction. Then that is called, this vector will be called negative of a vector. Negative of vector A. This is negative of vector A. Understood? So the negative of a vector is defined as another vector which has the same magnitude but have opposite direction. So this is another vector. Okay. Once we have understood this negative of a vector, we can easily work out to get this zero vector. Suppose you are adding vector plus negative of the same vector. What you will get? You will finally get zero vector. Null vector or zero vector. Mind it, this has got significance. We have to understand this. It has got good significance. So be very careful. Okay, magnitude is 0 and direction indeterminate. Okay, magnitude would be 0. Obviously, when you will add them up, A plus negative vector plus negative of a vector would give you 0 vector. 0 vector or null vector is a vector that has magnitude and an arbitrary direction. Magnitude 0, that has 0 magnitude and arbitrary direction. So this is called null vector or 0 vector. Understood? This is very simple. Now, next we will talk about the fixed vector or free vector. Be careful. Few vectors are called fixed vectors. Which one? Whose initial point is fixed. Vectors which have fixed initial point. Example, the position vector of a particle is fixed vector because its initial point lies at the origin. Oh, quite easy to understand. We have done it. Position vector, we have done it. Okay. Now, what is free vector? Free vector means the vector whose initial point is not fixed. Fixed vectors means the initial point is fixed. Free vectors whose initial point is not fixed. Example, velocity vector. Velocity vector of a particle moving along a straight line is a free vector. Wow. Easy, no? Position vector, we have understood. Position vector is called fixed vector because we are measuring it from the origin. Right? We are measuring it from the origin. Initial point lies at the origin. Okay? Alright. And free vectors have got not fixed initial point. That may be anything. Okay. Now, properties of zero vector. When a vector is added to zero vector, we get the same vector. That means, just have a look. If we have a vector A, we have null vector, we get the another vector, we get the same vector, right? We get the same vector. If we add a vector to the null vector, we get the same vector. That is the first property. Obviously, when a real number is multiplied by a zero vector, we get zero vector. Suppose lambda is a real number, 5, 3, 4, 5, whatever it is, 5, 4, 6, 0, 2, 9. So if a real number, if it is multiplied with a real number, if a null vector is multiplied with real number, it is going to be what? Zero vector. Understood? This is what we need to keep in mind. These are the properties that we have to keep in mind. Okay? If we multiply null vector with some real number, we will get the null vector, zero vector only. Okay? Now, when a vector is multiplied by a 0, we get 0 vector. When a vector is multiplied by a 0 vector, vector multiplied by 0 vector equals 0. Right? If lambda and mu are two different non-zero real numbers, then the relation this lambda a into lambda b can hold only if both a and b are zero vectors. That we have to, this is quite simple, no? 5 into 0 or 7 into 0. Those are equal, no? Final result is 0 only. That is the basic idea behind this. Now, we have done the types of vectors. We have understood what is vector. We have understood how a vector is represented. We have understood position vectors. We have understood how to find out the unit vector. So I want you to do one question based on how to find out unit vector, right? And in today's session, we will do few, one or two questions, couple of questions, and then we will move ahead. In the next session, we will talk about the addition of vectors. Okay, all right. So right now we will talk about the simple, how to find out unit vector. Suppose you have got a vector A equals 12 I cap plus 13 j cap. 12 I cap plus 13 j cap. Okay. How to get it? What we need to find out? Find the unit vector of A, this vector. Okay, so understand this. Unit vector means unit vector of A is written as A cap, which is equal to vector divided by its magnitude. How to find out the magnitude? We had talked about this. So magnitude of vector A, just write down. Magnitude of vector A. This equals A x component square plus A y component. what is the concept behind this? What is the logic behind this? Why we are saying this? I explain this thing. Have a look. Suppose we have a vector along this. Okay, this is x-axis, this is y-axis. X-axis and y-axis. Now from this, if we draw this, this has got its effect, its value along x-axis. The way we had found the coordinates, if you remember, we had done position vector, it had x coordinate, y coordinate of this. So similarly, it will have x coordinate value and value along y-axis, along x-axis and along y-axis, because we are taking it in a plane, 2D plane, right? Okay, so 2D. So what we will do, if we need to find out this result, this would be the magnitude, right? From here to here, from this to this, from this to this. Okay, what is the distance? How would you get it? It is very simple, no? This is AY, this is AY here, and this is AX here. AY and AX. Pythagoras theorem. If we have to find out this one, this will be AY square plus AX square. That is what we are doing. Pythagoras theorem, right? So magnitude we found. Put this thing. So magnitude would be 12 square plus 13 square. What you will get? 144 plus 169. What is the final result? Whatever it is, this vector divided by this. Actually, I was actually willing to take 5 plus 12. 5 plus 12. Right? So let us take this 5 plus 12. That would make the things, complete square root. Okay. So 5 square plus 12 square. What you will get? 5 square plus 12 square. Square root of that. So it is 25 plus 144. That means 169 square root of this. That means 13. That is 13. So what is the final result? A cap equals vector A divided by magnitude of vector A. That means, what was the vector? What was the vector? Vector was 5i cap plus 12j cap. So it is 5i cap plus 12j cap divided by 13. Very simple. So this could also be written as this, 5i cap plus 12j cap. So this is called unit vector of vector A. Okay, unit vector of vector A. So now you got the idea how a vector is represented. How a vector is represented. Okay, in the last session, lecture 2, we talked about how to find out velocity. You remember that? If x coordinate and y coordinates both are changing with time and we need to find out the velocity, net velocity, what would be that? V x square plus v y square, right? So magnitude of the velocity, we can draw it in this manner. Suppose this is velocity. Suppose this is velocity. Okay. Velocity is drawn in this direction. It is drawn in this direction. And it has got some, if x coordinate is changing, then this is Vx. If y coordinate is changing, this is Vy. So this V, magnitude of this velocity vector will be this. So you got the fair idea how to find out the magnitude of a given vector. Understood? Magnitude of a given vector. Here we had found the magnitude of the velocity vector. Right? So this was simple. This was simple. Now, we found the amplitude, that is, we call the magnitude, right? Magnitude of a given vector, that means length of the vector. Magnitude of a vector, that means length of the vectors. In the next session, we will talk about how two vectors are added together. How two vectors are added. So, there are different laws, parallelogram law, triangle law, polygon law of vector addition. Right? So we will discuss all the laws of vector addition in the next session. Okay? Till then, whatever we have understood, practice properly, stay tuned, work properly, right? See you in the next session. Thank you.